Have you ever wondered how the moon's gravity affects the Earth, or why Saturn has rings? These phenomena are all due to tidal forces, a powerful and often overlooked aspect of astrophysics. Welcome to a journey through the cosmos, where we'll explore the invisible strings that pull and shape our universe. These strings are called tidal forces, the silent puppeteers of celestial bodies. Born from the gravitational interaction between two cosmic entities, tidal forces are responsible for some of the most fascinating phenomena in the universe. Imagine two celestial bodies dancing in space. As they twirl, the gravitational pull between them creates a stretch, a tug, a distortion. This is tidal force at work. It sculpts the surfaces of planets, molds the atmospheres of stars, and even constructs the majestic rings of gas giants. From the moon's impact on our oceans to the creation of Saturn's iconic rings, tidal forces prove that gravity is more than just a force keeping us grounded. Now let's delve into the top 10 discoveries from the study of these remarkable forces. Starting at number 10, we have the discovery of tidal tails. Now, what are these, you might wonder? Well, imagine a celestial body straying too close to a larger one. The gravitational pull from the larger body is so strong that it literally tears the smaller body apart, creating a stream of material that we call a tidal tail. This is not some obscure phenomenon either. We see it in the universe around us all the time. Take comets, for instance. The spectacular tails that make them so identifiable are a direct result of tidal forces. And it's not just comets. Even galaxies aren't immune. Sometimes, a smaller galaxy will venture too close to a larger one, and the gravitational pull will stretch it into a long stream of stars. So next time you gaze at a comet's tail, remember the immense tidal forces at play. At number 9, we have the phenomenon of tidal locking. This is where tidal forces, those gravitational pulls and pushes that shape celestial bodies, slow down the rotation of a smaller body. Gradually, over time, this rotation becomes synchronized with its orbital period. The result? The smaller body always presents the same face to the larger body. Now let's take a real-life example that we're all familiar with, the Earth-Moon system. Our moon is tidally locked with Earth. This means that the moon rotates on its axis in about the same time it takes to orbit Earth. Because of this, the moon always shows us the same face. So that man on the moon you see, he's always there, never turning his back to us, thanks to the fascinating process of tidal locking. This is why we always see the same side of the moon from Earth. It's a testament to the powerful influence of tidal forces in our universe. Moving on to number 8, we have the concept of tidal heating. This is a fascinating process where the gravitational pull from a larger celestial body, such as a planet, can cause the interior of a smaller body, like a moon, to heat up. But how does this happen? Well, it's all due to the flexing and stretching of the smaller body's material. Think of it like a stress ball being continuously squeezed and released. Every time it's squeezed, it generates heat, and the same principle applies to celestial bodies. The constant gravitational tug-of-war, the incessant squeezing and stretching, creates friction within the smaller body's interior. This friction generates heat, leading to what we call tidal heating. Now, why is this exciting? Well, tidal heating is believed to be responsible for some truly spectacular phenomena in our solar system. Take Saturn's moon Enceladus, for example. Astronomers believe that tidal heating is the driving force behind the moon's geyser-like plumes of water vapor. Similarly, the volcanic activity on Jupiter's moon Io, the most volcanically active body in our solar system, is also thought to be a result of tidal heating. These are just a couple of examples of how tidal heating can shape and influence celestial bodies. It's a powerful process, and one that's crucial to our understanding of the universe. Tidal heating is a testament to the immense energy these forces can generate. At number 7, we have the formation of tidal bulges. Now, picture this. The moon, in all its celestial splendor, exerts a gravitational pull on our planet. This pull doesn't affect all parts of the Earth equally. It's strongest on the side closest to the moon, causing a slight elongation or bulge on that side. But here's the interesting part. There's another bulge on the opposite side of the Earth too. This happens because the Earth itself is also being pulled toward the moon, leaving the far side's water behind, so to speak. These two bulges in the Earth's oceans are what we refer to as tidal bulges. And guess what? They're responsible for the phenomenon we call tides. As the Earth rotates, different parts of the planet pass through these bulges, leading to high and low tides. This effect plays a crucial role in our planet's climate and sea life, so we have tidal forces to thank for our daily tides. Coming in at number 6 is the discovery of tidal friction. This fascinating interaction between Earth and the Moon is subtly changing the way we experience time. Here's how it works. The gravitational pull between our planet and the Moon causes the Earth's oceans to bulge, creating tides. This bulge, however, doesn't align perfectly with the line between Earth and the Moon due to Earth's rotation. The Moon's gravity pulls on this misaligned bulge, creating a torque that slows down Earth's rotation. This process, over billions of years, has caused our days to lengthen. Today, each day is a fraction of a second longer than the last. Meanwhile, the energy of the Earth's rotation is transferred to the Moon, causing it to recede from us at a rate of about 1.5 inches per year. So, the dance between our planet and its moon is not just a beautiful celestial ballet, but a powerful force shaping our perception of time. Tidal friction shows us that even the length of our day is not constant. At number 5, we have the Roche limit. This intriguing concept is the minimum distance at which a celestial body, held together only by its own gravity, will disintegrate due to tidal forces from a larger body. The gravitational pull of the larger body creates tidal forces strong enough to rip the smaller body apart, especially if the smaller body is made of weak materials like ice or rock, rather than sturdy metal. Let's consider a moon orbiting a planet. Close enough, the gravitational pull from the planet on the moon's near side is stronger than on its far side. This difference generates immense tidal forces. If the moon gets too close, within what's known as the Roche limit, these tidal forces can exceed the moon's own gravity that's keeping it together, causing the moon to break apart. But this destruction isn't necessarily the end of the story. The remnants of the moon don't just disappear into the void of space. Instead, they can form a beautiful, albeit destructive, ring system around the planet. This is believed to be how many of the ring systems we see in our solar system, such as those of Saturn, were formed. The glittering rings are actually the remains of moons that strayed too close and were torn apart by tidal forces. So the Roche limit isn't just about celestial destruction, it's also a creator, a sculptor of the cosmos. Next time you marvel at Saturn's rings, remember the Roche limit. Moving on to number 4, we have the role of tidal forces in studying exoplanets. This fascinating discovery has propelled our understanding of the universe, pushing the boundaries of what we thought we knew about our cosmic neighborhood. When we speak of exoplanets, we're talking about planets orbiting stars outside our solar system. These alien worlds, hidden in the vastness of space, are often difficult to spot. However, tidal forces have provided scientists with a unique method to detect and study these distant planets. Imagine a star, millions of miles away, quietly burning in the depths of space. As an exoplanet orbits this star, it exerts a gravitational pull, causing the star to wobble ever so slightly. This wobble, or tidal force, can cause changes in the star's brightness, a phenomenon scientists can observe from Earth. This observation is akin to seeing the effect of a pebble dropped in a pond from a distance. The ripple, or in our case the change in brightness, is the clue that something is there. By observing these changes over time, scientists can infer the presence, size, and orbit of an exoplanet. The study of tidal forces has therefore opened up a new window to the universe, allowing us to detect and study planets far beyond our own solar system. This discovery has significantly expanded our search for alien life, offering a new perspective on our place in the cosmos. Tidal forces are another tool in our quest to find alien worlds. At number 3, we have the fascinating relationship between tidal forces and black holes. The gravitational pull of a black hole is so intense, it creates an extreme version of tidal forces, known as tidal disruption, or more colloquially, spaghettification. Imagine a spaceship approaching a black hole. The gravitational pull on the spacecraft's side closest to the black hole is stronger than the pull on the far side. This differential creates an elongating effect, stretching the spaceship into a long, thin shape, much like a piece of spaghetti. It's a violent and, quite frankly, a fascinating phenomenon that happens in the vicinity of these enigmatic cosmic entities. But why does this happen? The answer lies in the nature of gravity itself. Gravity isn't a uniform force, it weakens with distance. So when an object is close to a massive body like a black hole, the side of the object closer to the black hole experiences a stronger gravitational pull than the side that's farther away. This difference results in a stretching force, leading to spaghettification. Black holes, with their enormous gravitational influence, are the ultimate manifestation of tidal forces. They take this everyday phenomenon we see on Earth, the tides, and amplify it to such an extreme level that it can rip apart anything that dares to come too close, from a rock to a star, and yes, even a spaceship. In the realm of black holes, tidal forces take on a whole new level of intensity. Coming in at number 2, we have the role of tidal forces in galaxy formation. Picture this. Two galaxies, seemingly minding their own business in the vast cosmos, suddenly find themselves caught in a gravitational dance. They start to pull at each other, their gravity acting like invisible arms, reaching out across the light years. This is where tidal forces come into play. These tidal forces are incredibly powerful, capable of stretching these galaxies out of their usual forms. They can even rip stars from their host galaxies, flinging them out into the cosmic void. But these aren't just destructive forces. They're also creators, sculptors of the universe on a grand scale. When galaxies interact, they can merge, their stars and gas swirling together to form a single, larger galaxy. This process can take billions of years, but the result is a new and unique galaxy, one shaped by the tidal forces at work during the merger. Other times, these interactions can warp a galaxy, distorting its shape into something entirely different. Some of the most beautiful and intriguing galaxies we see today are the result of these gravitational tugs of war. So, the next time you look up at the night sky, remember this. Those distant points of light aren't just static, they're part of a dynamic, ever-changing universe. The galaxies they belong to are constantly evolving, shaped by the tidal forces at work between them. Tidal forces are literally shaping the universe. And finally, at number 1, we have the most fascinating discovery, the role of tidal forces in the emergence of life. There's a captivating theory that suggests tidal forces could have been instrumental in sparking life on our very own planet Earth. You see, billions of years ago, our moon was much closer to Earth than it is today. This proximity resulted in extremely high tides, causing a vigorous churning of Earth's oceans. This could have promoted the mixing of chemicals, forming a sort of primordial soup. In this soup, the right elements might have combined in just the right way to create the very first life forms. Now let's fast forward to the present day and take a trip through the solar system. We land on Europa, one of Jupiter's moons. But don't let its icy surface fool you. Beneath this frosty exterior, tidal forces are at work. Europa is subject to the immense gravitational pull of Jupiter. This gravitational tug-of-war generates what's known as tidal heating. This process causes the moon's interior to heat up, potentially creating a subsurface ocean beneath the icy crust. Scientists believe that this subsurface ocean could be twice the volume of all Earth's oceans combined. Imagine that. Now, if we couple this with the heat from tidal forces, we have the perfect recipe for a habitable environment. This means that Europa, in spite of its icy exterior, could potentially harbor life. So, while tidal forces can be destructive, shaping celestial bodies and tearing comets apart, they might also be the unsung heroes in the story of life. From the primordial soup on early Earth to the potential subsurface oceans on Europa, tidal forces have shown that they are more than just cosmic sculptors. They could be the catalysts that spark the miracle of life in the harshest of conditions. In the grand story of life, tidal forces may have played a crucial role. So there you have it, the top 10 fascinating discoveries from the study of tidal forces. We've journeyed through tidal tails, tidal locking, tidal heating, and more, all manifesting the immense power of these forces. From the creation and destruction of celestial bodies, to the profound influence on exoplanets and black holes, and even their potential role in sparking life, tidal forces have shown their pervasive presence. From shaping galaxies to possibly sparking life, tidal forces truly are a fundamental force of the universe. And now, as we draw this cosmic journey to a close, we'd love to hear from you. Did you learn something new from our exploration of tidal forces? If so, show your support by giving this video a like. We're eager to hear your thoughts and opinions on these fascinating discoveries, so don't hesitate to drop a comment below. Remember, every like, share, and comment helps us bring more such content to you. So, if you've enjoyed our journey through the universe today, Don't forget to subscribe and press the bell icon. This way, you'll stay updated with all our latest content. And finally, let's spread the knowledge. Share this video with your friends and families. Who knows? Maybe you'll spark a conversation about the mysteries of the universe at your next family dinner or friend gathering. As we've seen today, tidal forces are everywhere, influencing our world and beyond in ways we're just beginning to understand. So, until our next cosmic journey, stay curious and keep exploring.